Welcome to part 3 of our GD&T series. In this video, we take a deep dive into position tolerance, one of the most widely used GD&T controls in automotive, aerospace, and manufacturing industries. Using a real steering column mounting bracket, you'll learn why controlling the location of a hole is more important than controlling only its diameter. Imagine you're assembling a steering column. Every mounting hole is exactly 10 mm in diameter, but the bolts still don't fit. How is that possible? The answer is position tolerance. Today, we'll understand why engineers care more about where the hole is than just how big it is. In the previous video, we learned how to read a feature control frame. Today we'll focus on one of the most important geometric characteristics inside that frame, the position symbol. What is position tolerance? Position tolerance specifies how far the center of a feature is allowed to deviate from its true theoretical location. Position tolerance controls the exact location of a feature, such as holes, pins, slots, bosses. It ensures that the feature is manufactured in the correct location relative to the datum references. Now let's understand this feature control frame. Don't worry, it looks difficult at first, but it's actually very simple. Let's look at each box one by one. The first box shows the position symbol. This tells us what we are controlling. In this case, we're controlling the position or location of the hole. The second box shows diameter symbol 0.20. This means the center of the hole must stay within a 0.20 mm cylindrical tolerance zone. If the hole center stays inside this limit, the part passes. If it goes outside, the part fails. The third box is datum A. This is our primary reference surface. All measurements start from datum A. The fourth box is datum B. This is the secondary reference. It helps locate the part in the second direction. The fifth box is datum C. This is the tertiary reference. It fixes the final position of the part. So, the complete meaning of this feature control frame is: the center of the hole must stay within a diameter 0.20 mm cylindrical tolerance zone when measured from datums A, B, and C. Now let's understand position tolerance using a real automotive example. Here we have a steering column mounting bracket. It has 4 mounting holes that are used to attach the steering column to the vehicle. For the steering column to fit correctly, all 4 bolts must align perfectly with these holes. Now imagine the drawing only specifies the hole sizes, diameter 10 plus or minus 0.05 mm. This means each hole must have a diameter between 9.95 mm and 10.05 mm. Suppose all 4 holes are manufactured with the correct diameter. Everything looks good, right? Not necessarily. If even one hole is slightly shifted from its correct location, the bolts will no longer align with the steering column. As a result, the assembly becomes difficult or may even fail. This is where position tolerance comes into the picture. The feature control frame specifies that the center of each hole must remain inside an imaginary cylindrical tolerance zone of dear 0.20 mm. If the hole center stays inside this tolerance zone, the part passes inspection, and the steering column fits perfectly. But if the hole center moves outside this tolerance zone, the part fails inspection because the bolts may not align correctly. So remember this simple rule: hole diameter tells us how big the hole is. Position tolerance tells us where the hole must be. And in automotive engineering, both are equally important for a successful assembly. Once the part is manufactured, the next step is inspection. Quality engineers need to verify that the hole locations are exactly where the drawing specifies. To do this, they use different inspection methods. The first is a coordinate measuring machine, or CMM. It accurately measures the center of each hole and compares it with the drawing requirements. The second method is functional gauges, also called go, no-go gauges. These quickly check whether the part will fit during assembly. The third method is vision systems. Cameras and software measure the hole positions without touching the part, making them ideal for fast production line inspections. No matter which method is used, the goal is the same: to verify that the center of every hole remains within the specified position tolerance zone. If the hole center is inside the tolerance zone, the part passes inspection. If it is outside the tolerance zone, the part fails because it may cause assembly problems. That's how manufacturers ensure every steering column bracket fits perfectly in the vehicle. Thank you for watching. See you in next video.